Consider the indefinite integral. This can be transformed into a basic integral. So we're trying to do the antiderivative of the integral of that, and that looks totally tough, but we can transform it, we can change it into an easy integral by letting u be something. You see the answer here. Why is that the answer? Well, you see how this is x to the fourth minus 8, and this is x to the third. Whenever you have two things and one is one power higher than the other, let u be the higher power because then the derivative will bring it down, right? You subtract, we bring it down and subtract one from the power, it'll match the other one. So always let u be the higher power. Also, we let u be the one that's inside. If it's inside of a root or inside of parentheses or a natural log or a sine or a cosine, you usually let u be the thing that's inside or the thing that's the higher power by one. That's both. So we're going to let u be x to the fourth minus 8. So all of this becomes u. Okay, now if that's the case, let me bring it over here. U is x to the fourth minus 8. Then let's take the derivative du dx of both sides. Remember derivatives? The 4 comes down, subtract 1 from the power. X to the minus 8 goes to 0. And then multiply both sides by dx over 1 times dx, and we get du is 4x cubed dx. Du is 4x cubed dx. So there it is. Du is 4x cubed dx. All right, so now if we want to change this integral, um, here's the trick. We've got to replace x cubed and dx. So that means multiply both sides by 1/4. This cancels. 1/4 du, that's a 4 there, 1/4 du is x cubed dx. So that means x cubed dx, these together are 1/4, that's a 4 again, du, or 1/4 du. So this integral here becomes the integral of, this is the third root of u, and I'll stick the 1/4 in the front, du. 1/4 cube root of u du. Do you see how that happened? We let u be the higher power, x to the fourth minus 8. Take the derivative of both sides, multiply it over the dx. And then we had x to the fourth minus 8, third root of it, became third root of u because u is in what's inside that root. So third root of u. And then the x cubed dx, well, I was able to find x cubed dx by multiplying both sides by a fourth. X cubed dx is 1/4 du. So x cubed dx, replace that with 1/4 du. So there's our integral. So now we've changed our integral to be a nice, easy integral, right? That we can do. In fact, I'm going to rewrite this. This is 1/4 integral of u to the 1/3, right? You remember, you aware of that? Roots are fractional powers. So that's just a rewrite. And it'll take that answer as well. It knows those are the same. That's a rewrite. So third root of u is the same as u to the 1/3. Roots are fraction powers. Okay, so now what do I care? Because now I can do the antiderivative of this so much easier than this original crazy thing. I can do the antiderivative of that. How do I do it? Let's do it. I'll bring it down here. I'm going to do the antiderivative because that's what this integral in the front and this du at the back together, they will act upon this. 1/4 is just going to sit in the front. And I'm going to do the anti, and the integral will vanish. He's doing his job. How do you do the anti? Well, you add 1 to the power, add 1. So that'll become 4/3, right? 1/3 plus 1, 1/3 plus 3/3 is 4/3. So when I add 1 to the power, it becomes 4/3. And then I'm going to, instead of dividing by 4/3, the easier thing is to multiply by the upside down. Multiply by 3/4. That's the same effect as dividing, right? Because normally we add 1 to the power, 1/3 plus 1 is 4/3, then we divide by 4/3. But instead, multiply by 3/4, same thing, multiply by the upside down. Okay? And so that's what we've got right here. 1/4 times 3/4 u to the 4/3 plus a constant. Last step. Now we can go back to x. We can say, oh, okay, well, this is 1 fourth times 3/4. And instead of u, what was u all along? U was x to the fourth minus 8 to the 4/3. There it is. 1/4 times 3/4 x to the fourth minus 8, because that is u. That's the u. So we did the antiderivative. What did we do? We took this original, terrible looking antiderivative integral thing. We said, wow, this is x to the fourth, this is x to the third. Let u be the inside. Then take the derivative, goes down one level, multiply by the dx, and then multiply by the 1/4 to get x cubed dx, which is 1/4 du. So we changed it all to u, rewrote it as a 1/3 power, did the anti. Now we can do the anti and get rid of the integral. Add 1 becomes 4/3, multiply by the upside down, and then change back to x. So we changed to u because the integral was so much easier, the antiderivative. Then we went back to x in the end. We used u in the middle. And so there we go.